You can broadcast for 8 hours.
That's what it says. You can broadcast for up to 8 hours. Yeah, no, thank you.
I just don't have that much to say. 8 hours.
I don't either. Or that anyone would watch it.
Yeah.
Okay, so true, true. Okay.
Hold on. I think I had a pen and then somebody came and took it.
Oh, I totally understand.
Oh, there it is.
I
Okay.
have to do that too.
All right.
Okay. So, okay, for the first question, for the next 9 questions, we'll review the PTC tasting study with different data. Out of 70 females in the sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC. Please use the data presented here. Let P1 be the proportion of females in the population who can taste PTC. And let P2 be the proportion of males in the population who can taste PTC. The research question for the study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC?
Okay.
So we need our spreadsheet. Having thousands of windows open. Okay. Okay, so
P1 would be 18 divided by 70. Wait. P1 is proportion of females who can taste it. So that would be 52 divided by 70.
Yes. And the guides would be 42 divided by 59. So P hat 1 in the spreadsheet, it says it's 0.743. Is that what you got?
Yeah. I just did it with
Okay.
my computer.
Oh, gee. And P hat 2 is 0.712 is what the spreadsheet said. Is that what you got?
Yep.
Okay.
Let me type those in. 0.743 and 0.712. Oh, sorry, somebody turned my
that's okay.
numbers locking on. My husband will use this laptop to watch movies, and for whatever reason, he puts the number, like locks the number pad, which is really annoying.
Yeah, my kids do that on our computer. They turn off the number lock so they can play games.
Yeah, I'm like, leave it on. It's annoying. Okay, which set of hypotheses is appropriate for addressing the research question? So we want the P1 and P2 to be equal for the null, then the P hat would be not equal.
Let me make sure that was the question. Yes, not equal.
Okay.
So it's number A, isn't it?
Yeah.
Okay.
Okay, so we need to do a 95% confidence interval. The point estimate, what is that?
I don't know. I was hoping you did because I'm sitting here. What?
Is the point estimate like the z-score?
Let me check. I'm looking. don't know what the point estimate is. Let me look in the class. They like changed, they have like different names for everything.
Yeah.
I know by one name and then it's like, what? What's that?
Exactly. So they call the z-score the test statistic, but that
Right.
seems like that would also maybe be the only one that could be the point estimator.
So what, okay, what was the term again?
Point estimate.
Okay. A sec, I'm trying to.
Okay, I just looked it up on Google.
Oh.
So it says the point estimate involves the use of sample data to calculate a single value, which is known as a statistic, which serves as a best guess or best estimate
So
of
is
an
that
unknown. That sounds like it would be this test statistic, which is the z-score.
I'm almost in the textbook.
Okay.
The textbook. Point.
Oh, right.
Okay, we're on lesson 18.
Uh-huh.
Not. It just stalled. It just stalled.
Yep.
Okay. Test statistic. So we're going with point estimate. I'm like, I'm not, like it's in there, but of course my computer decided to, now I can scroll. Okay. I'm still not. Okay, we can, yeah, so what are, we're gonna put the Z value there?
I guess so.
Okay. I'll have one of us go first.
Okay, because some of these other things I'm reading are saying that like the sample mean or the proportion mean is the point estimate.
Okay, so let me Google it. Point estimate. But you can search the textbook, but then it doesn't take you to there. It just takes you to the lesson, which is annoying.
Yes. That is annoying. Okay. Oh, Kyle just texted and said he's not going to be available for the next 2 meetings.
Okay.
I think he
Ask him what a
texted
point
me.
estimate is.
Huh?
Ask him what a point estimate is.
Huh, okay. Okay, I just sent him a text.
Okay.
All right.
Okay.
Point estimate. I vaguely remember learning about it.
Yeah, and I know I've read it and reread it and
Yeah. Okay. And
one more time. So
all right. So do we just want to skip that one for a little bit and come back to it, or?
yeah.
Okay. So the margin of error for this confidence interval . It didn't give us a margin of error formula.
Of course.
In the lesson, which means we have to look it up in one other lesson.
Right.
Okay.
Well, so wouldn't it be? Would it be like the confidence interval subtracted from each other, or is that something else?
I don't know. I'm not sure. What's wrong? He's being mean.
Yeah.
I'm sorry. You guys want to go play with your toys?
No, my turn. Mom, it's Hannah's turn. I mean, still my turn.
It's really your turn.
Yeah. No, I'm not in that. Mom,
Yeah.
we need some water.
You want some water?
No, water.
Be nice, please.
No, water. Mom. Mom.
I'll help you in just a minute, okay?
No.
Roy, can you go turn on a show?
I don't know how to.
Can you turn on Hannah's favorite show?
Yeah.
Okay,
But I don't know how.
just go turn on any show.
I don't know how.
You don't know how. Let's go. All right, I'm looking at the reviews for the different.
Right. Ooh, somebody texted us back.
Oh, okay, this Kyle. Isn't that the estimate of the population parameter? He says he remembers reading that, but can't remember where. Like the rest, both of us. That's funny. Okay, here is a margin of error formula. It's z times sigma over the square root of n. So we don't have sigma, do we? Oh, yes, we do. Standard deviation. Too much stuff. Wait, do we have to do a margin of error? Well, for the total number, which would be 129.
So, okay. And question 8, isn't that like the confidence interval? And wouldn't that just be like the negative?
Question 8.
Yeah.
Input. Yeah. So I was looking at 7. Did you do 7 already?
No, I'm looking at 7, but would that be, would you subtract the upper bound from the lower bound to get the margin of error and divide by 2?
I don't know. We've done that a couple of times and it's been wrong, but we can try it and see if it's right. That's fine. That works for me.
I'm just like, yeah, I don't know what else to do. So, okay. And it's the upper minus the lower.
Upper is 0.185.
Right. Minus the lower, which is
negative
1.23 equals divided by 2. I got 1.54. 0.154. Is that what you got?
No, I got 0.308.
Divide by 2.
Oh. Okay. Forgot that part.
We always do.
Yes. Because I have to do the little parentheses around the negative thing, and then it makes me forget what I was.
Right. I totally understand.
So funny. Okay. So oh wait, that goes on number 7. I put that in the wrong box. Hold on. 1 by 4.
Oh, we never did do the point estimate.
Yeah.
Okay, I'm gonna leave that blank so I don't accidentally. Is that?
The lower bound is negative 0.123. And the upper bound is 0.185. Okay, are you ready for number 10?
Yeah. I was just looking at the others for just a second, trying to find number 6.
Okay.
Because I remember reading something somewhere with all the formulas.
So in the dictionary or the glossary or whatever, it says a point estimator is one number that is used to estimate a parameter.
Right.
But I don't know how to. Oh, it's in lesson 10, huh? Any number of it can. The statistics above are called point estimators because they're just one number, one point on a number line. So the mean, the standard deviation, the variance, sample mean, population mean, all of those point estimators.
Is it just our p hat score?
I think
like an
so.
overall p hat?
Yeah.
Okay, which is x1 plus x2 divided by n1 plus n2, right?
Yes, maybe. I have to look at it.
Maybe.
Are you looking at it right now?
Yeah, I'm looking at the test statistic where you like figure that out.
Okay, so the regular P was x1 plus x2.
Yeah. So it'd be 52 plus 42.
Okay, divided by n1 and 2, so that would be 70 and 59.
Yeah.
59. Okay.
I got 0.7286. So I'm 29.
You got 0.729
Yeah.
rounded? Okay. That's what I got also.
I don't know if that's right, but
We will see.
yeah.
29. Okay. So number 10 then. With a level of significance of 0.05, what decision do you make? So our piece value is 0.693, which is greater than 0.05.
So
we fail to reject the null.
Yep. Okay. So it's A.
Yeah.
Okay. Which of the following statements best describes the outcome of the study? There is insufficient evidence to suggest that the true proportion. Okay. So it's D. There's insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PC.
Okay.
PTC.
Yep.
Bottom one.
PC. Okay, for the next 9 questions, we will review the mortality rates and day of admission heart attack study with different data. Out of 118,519 people who had a heart attack during a weekday, 16,713 had died. That seems like a lot. Out of 42,447 that had a heart attack on the weekend, 6,155 had died. Please use the data presented here. I'm going to write it down so that I don't have to scroll back up.
And it's the people who died. Well, I'm going to put it in my spreadsheet. The people who died is 16713 versus 11859.
Okay, so P1 is the proportion of patients who had a heart attack and were admitted on a weekday. So that would be the total of people that had heart attacks?
So X1 is the died, the 16713, and then the N2, N1 is the 118519.
Okay, I see. 16,713.
And then the X1 is X2 is the 6,155, and the N1 is the 42,447.
Okay. 19 by 19. 6,155.
They want it less than. The group wants to be less than group 2. Okay.
Yeah, 42, 4.
And all the numbers check for the hypothesis test.
Okay. So what's the first question then?
Okay, sorry. And it's less than, right? So like,
yeah.
Okay, got it. I had it greater than. So yeah, you gotta mark all those little things. It'd be D, wouldn't it?
For the first, for 13?
For 13, yeah.
Let's see, D. Yes.
Okay.
Yep.
Okay.
14. This is a lot of questions for today.
Yeah. Okay, so the data is P-hat1 is 141, according to the spreadsheet.
0.141, okay.
Yeah, 145 for P-hat2.
P-hat 2, is that the one you were saying right now?
Yeah, it's 145, 1.145.
Okay.
And the Z-score, I got negative 2.02.
Yep. You get a 2.02. Wait.
Okay.
020. Okay. It's like I'm missing a number. There it is.
And we shade it to the left. Right?
Hold on. What should shade? So yeah, the left side.
Okay. 0.022.
Okay, the p-value. Yep. 0. I kind of like these ones where the spreadsheet just has it all.
Yes.
Okay, what is the decision for the test? So our confidence is 0.05 or level of significance. And the p-value is 0.022, which is less than 0.05, right?
Right.
So then we reject the null.
Right, yeah. So since we're rejecting it on null, it's sufficient evidence to conclude that yes, you're more likely to die.
Die is okay. So it would be C.
C, yeah.
Okay.
Okay. Do you want me to submit my test first?
Sure.
Okay.
We're mostly just looking at that margin of error one.
Yeah.
Okay.
Yeah, that point estimate thing.
Did we get that one right or wrong?
I'm looking.
Okay.
Okay. We did not get the point estimate right. We did get number 7 and number 8 right. And number 9 and number 10, number 11, 12, 13. Okay.
So we did get number 7 right. Okay, good.
Yeah, so the only one we missed is 6.
6. Okay.
So we got a 95. But the only one we missed is 6. So it's not 0.729.
Okay.
So let me put my papers in order here, and maybe I can find where it says point estimate in this textbook of ours. Actually, let me actually, a sec. Okay. Let's see if I can do this.
Oh, wait. So an interval estimate is a range of plausible values for a parameter. We create an interval estimate by starting with the point estimate and adding or subtracting the margin of error. That's kind of like the lower and upper bounds of your confidence interval, right?
I think so.
Okay. So so the confidence interval problem for this lesson, we took p hat 1, subtract p hat 2, and then we subtracted it from the z-score squared. We add or subtracted it. So would our point estimate be then p hat 1 subtract p hat 2?
Right here. So where is that?
It's in this week's lesson in the Fox tracks section, the tracks of the Fox.
Right, okay. Fox tracks. So 15, 16. So what are you saying?
So I'm saying that the point estimate would be p hat 1 subtract p hat 2.
Okay.
That's what we add or subtract to the rest of the equation for the confidence interval.
And what do you, so
let me
it'd be
put
like,
that in, see if I get it right or wrong.
okay,
0.031.
okay.
And then if that's not it, probably just have to ask somebody, like the teacher.
Yeah.
Okay, submitting. So number 6 was correct.
You got it right?
Yeah.
Okay, so what's the answer? So how did we get it?
So we took the p hat 1 and subtracted it from p hat 2 on our spreadsheet.
Okay.
So that gave
And
us
that is our
point.
point estimate?
Yeah.
Okay. Yay. Okay.
And I'm gonna write that on the board.
So you got 100%. Yay. So I'll go back and redo mine.
Awesome.
Okay.
I like it when we can figure it out. Makes me less stressed out. Yeah.
Yes, because then when it shows up on our test, it's not a big deal. Okay. So I'm going to stop the broadcast and then I will find the link and post